Hello again, John here, and welcome to tutorial 3 of the 6502 videos. And in this tutorial we're going to do a bit of a deep dive into the different addressing modes of the instruction set, and we're going to go into the instruction set as well to try and explain what each instruction does. So this may be one or maybe two videos depending on how long it is. I don't want, maybe even three. I don't want to make it too long that people get bored. So this is a small presentation. So what I'm going to do is I'm going to try and talk about the addressing modes, but only in the context of one instruction. So the instruction I've picked is the load accumulator instruction. So the load accumulator instruction allows you to load a number from wherever into the chips at the chip registry called the accumulator. So this means that you can say load 5 into the accumulator, and that will result with the accumulator having the contents of 5. Now the thing is that the load accumulator instruction has 1, 2, 3, 4, 5, 6, 7, 8 different variations. So, and these are what we call addressing modes. So it has a variation called immediate, it has a variation called 0 page, a variation called 0 page comma x, absolute, absolute comma x, absolute comma y, indirect indexed x, and indirect indexed by y. And I went through these addressing modes in the previous video, but what I'm going to do is I'm going to try and explain each one of those addressing modes one at a time. So we're only concentrating on the load accumulator. So we're taking data from memory or the program and loading it into the accumulator. And this instruction has an effect on these two statuses in the status register. So when you load the accumulator, the N flag is fired and the Z flag is fired. So when you load the accumulator, you can test whether it's equal or not equal to 0, or whether it's negative or not, and that's to complement negative as well, right? So the first one is 0 page addressing. So in this instruction I've put on here load the accumulator from position 32 in the memory. So position 32 is a 0 page data point, and the reason why they've got a 0 page data point, because if you can still use the absolute addressing mode, but the absolute addressing mode takes 3 bytes, because it's load the accumulator, which is 1 byte, and then 0032, which is then and further 2 bytes, because you've got 0032. So you don't have to do that. You can actually use this instruction instead, which is the load the 0 page one, and this allows you to only use 2 bytes, which is LDA, which is 1 byte, and then 32, which is 2 bytes. So what it does, it tells the 6502 to go to 0 page and find location 32 in hex, and then it's that value of D6 in 32 is then loaded into the accumulator, and it's as simple as that. So the next addressing mode is a 0 paged index by x, and what this addressing mode allows you to do is to say load the accumulator from position hex 22 but add x to it. So in this case we've got the x register is 6, so the CPU will go 22 plus 6 is hex 28. So it goes to 0 page, and then 22, that's 21, 2, and then because of x has been 6, it'll be 1, 2, 3, 4, 5, 6. So that memory location has 45, which is then loaded into the accumulator. If the X register had been 3, it would have been 1, 2, 3. And it would have been 0, 0 that would have been loaded in. So this allows you to say, go to this point and then add X to it and give me the value. Now, absolute addressing is simply that. You are telling the 6502 to load the accumulator with the value that's in that point. So in the one on the screen, we're saying load the accumulator with the data that's contained in address point 32FF. So it immediately goes off into RAM, looks at 32FF, finds AC, and then loads it into the accumulator. And that's all it does. It will not do anything else. And that's a simple addressing mode. We have the same as the previous addressing mode, but this time it's indexed by X. So, as in the previous one, you were saying load the accumulator from point 32F0, but add X onto that. So currently X is OB. So we're saying load the accumulator from 32F0, add OB to it, which results in a memory address 32FB, which is here, and then loads the value of that address into the accumulator. We also have the absolute with the Y register as well, because if you look back, we've got absolute with X and absolute with Y. So that's the only it's the only addressing mode that allows you to index on the same method by X and Y. The next addressing mode is zero page indexing by X, and this is slightly different. This is saying look at the address 20, add X to it, find the address at 20 plus X and 20 plus X plus 1, then go to that memory and find me what's in that memory. So in this particular case, we're saying look at zero page addressing mode, address location 20, add OB, so it's coming here, there's 20, OB is here, then load this address, which is AC30, which is over here somewhere, yeah, and this is 20, so this is 30 here, if this is 2B, C, D, E, F, 30, which contains FF, and then it loads that into the accumulator. So it's not saying load the accumulator with the value in 20 plus X. It's saying load the accumulator with the address that's contained in 20 plus X and 20 plus X plus 1. And so it looks for two values, creates an address out of that, and then goes to that and gets the value. Gets a bit slightly more difficult, these addressing modes, because instead of it just being a simple go get an instruction, it's actually go get the address that I need to go get the value from. And then the last one is slightly different than the previous one, because this is saying look at location 20 in zero page, find me the address at location 20 and 20 plus 1, then when I've got that address, add Y to it. So in simple cases again, so 20, so if this is 1D, 1E, 1F, 20 and 21, so it's saying right, look, I found the address at 20, which is AC30, go to AC30, which is here, BBC, and I've actually got this wrong, but never mind, and then add Y to it, which is 4. So if this is AC30, then it's 1, 2, 3, 4, and it's this value that it then loads into the accumulator, not this one. So I've made a mistake. So what it's doing is it's going to zero page 20, and it's saying get me the address that's located at zero page location 20 and plus 1, then go to that memory address that's located at that point, then add y to it. So just to re-establish, 20 and 21 are saying go to memory space address AC30, which is here, then add the Y registry, which is 4, 1, 2, 3, 4, which is A0, and then load that into the accumulator. So what I'm going to try and do is I'm going to try and go through each one of these addressing modes for you, but in a development environment. So we'll start off with a simple one, which is immediate, which is basically load this value straight into the accumulator. So here we are. Let's just make this screen a little bit bit bigger. Let's just do a couple of those. There we go. So I've written this tutorial 3 program, and what this tutorial 3 program allows me to do is, so we're going to write all our machine code here to demonstrate, but I've created a routine called print accumulator, and what print accumulator does is down here. Yeah, so print accumulator allows us to print out the accumulator onto the screen, and I'm not going to go through all this because I don't think it's relevant to the thing, but we can go through it through a later date. And what it does is I've created the first one, which is saying, now this is load the accumulator with the number DC. So we're doing the first addressing mode, which is immediate, and immediate says just load this number that I'm telling you into the accumulator, and then I'm printing the accumulator. So what I'm going to do is I'm just going to rem these out here because they're not relevant, and what it does is going to print out DC onto the screen. So if I run it, there we go. So it's printed out DC, so this is the binary representation of DC, the hex representation and the decimal representation, and that is printing out what the contents of the accumulator was. Okay, so that's just to show you what immediate does. It loads the number that's contained in here with DC and then prints it out. So the next mode was the 0 page mode. So we'll go back, and this time we're going to say load the 0 position DC and then print it out. So we'll run it again. So this should go to the memory location DC and get me the value, and it says it's 84. And the way to find out if this is true, we'll go into monitor and we'll go into memory inspect. We'll go to DC. Oops, a bit quick. My finger's a bit quick. So D8B DC. It reckons that in DC is 84. And what did we get? 84. So that's showing you it's gone to the memory location in 0 page called DC and got us the value. So I am now, we'll go to the next one. So this is load 0 page index by X. So I'm just going to run it again because I want to find a memory location that is going to be different, because I noticed that when we looked into that monitor space, DC had the same numbers. So what I'll do is we'll find a location that's got varying numbers. There's not many of them. Right, so there we go. So what we'll do there. So what we'll do, we'll say we're going to look at 80 and then add X, and we'll get these different values. Okay, so the memory space address we'll use is 80. So first things first is we're going to load X with 0. Then we're going to load 0 page 80 and X. And we're going to print the accumulator out, but then I'm going to load the X with another value, and we'll say 08, and we'll do the same instruction again. So 0 page location, but this time add X to it. So we should get two numbers. We should get the value from 80 plus 0, which is location 80, and the next one we should get value 80 plus 8, which is 88. So we should get two numbers, and when we run it we will go into the memory and check. So right, where was I? Sorry about that, I had a phone call from Retro Marky and it's put me right off my stride. Right, where was I? Oh yeah, here we go. So we're loading X with 00. I apologise if I've already gone through this. We're going to load the value into the accumulator from point 80 plus X, which is 0, so it's point 80. We're going to display it on the screen, and then we're going to we load X with 8, and then we do the same thing again, but this time instead of looking at memory location 80, it's going to look at memory location 88, because X will be 8 plus 80, and we're going to display that on the screen as well. So we'll see what this addressing mode looks like. So we'll run the emulator, and there we go. So at point memory location 80, it reckons it's C9, and memory location 88 is E9. So we'll have a quick look in there. So memory location 80. There we go. So that's 82, 80. So C9 at memory location 80, which is what we've got, and then at memory location 88 is E9. Oh, I love it when a plan comes together. So that is 0 page and indexed by X. The next one is to load a value directly out of memory. So to do that, we'll just change this slightly. We'll get rid of that. I'll rem out this just in case I need it again, and we'll load a value directly from memory. So we will load a value from FFD5. So this is we're going to load into the accumulator the contents of the memory location FFD5. Now I know something will be there because it's one of the jump vectors that the Commodore Basic and kernel uses. So we'll see what value it is. And so just going back to here, we've told it exactly the memory location. We're going to get it and load it into the accumulator. So let's run it and see what it comes back with. So it's come back with 4C. So we will look at the memory location FFD5, FFE, FF5, FF7, FF9, D5, 4C. Is that what we got? Yes, it is. So that's loading into the accumulator the contents of the memory location FFD5. The next addressing mode is the location but indexed by X. So we'll do the same thing again. We'll load X with 0, and we'll do FFD5, X, and then we'll do the same thing again. Load X with 8, and we'll do the same memory location FFD5, X. So this is FFD5 plus X, which will be A, B, FFCD. So FFDD should be. And we'll print out the two memory locations. So we already know what this one is. So this should come back with the same value as we had when we did the absolute. So we'll just run it and see what it comes back with. There you go. So 4C, which is correct, and it says that it's F6. Right, let's have a look and see if we're right or not. So FFD5 plus 8. Here we go. So FFD5 plus 8. So 1, 2, 3, 4, 5, 6, 7, 8, which is FFDD. Oh, look at that. That was bang on. And it's F6, which is what we've got down here, F6. So that's absolute addressing indexed by X. And it's the same with index, it's the same with Y as well. So if we did this exactly the same but loading Y instead of X, we would get the same result. So, next one, which is 0 page indexed by X. This is different, right? Because what you're doing, so we'll do the same thing again. It was 80, wasn't it? Yeah. Comma X. So what we're doing is saying, look at 0 page location 80, add X, in this case it's 0, and print us out. And we'll do the same with here. So this will be 88 and print out the value. Right? But you've got to remember that this is taking the address of 80 and then printing it, and the address of 88. So here we go. So this is going to take a little bit of working out once we've done it. So it's come back with FF and F3. So let's move that there, get the monitor up. So we need to figure out what were at memory addresses 80 and 81. So we'll go to memory address 80 and 81. And 80 and 81 was 20 C9. So we then go to 20 C9. And the address was FF, which is correct. That's what we got from the first one, FF. Now the second one was, think about it, 88, because it was 80 plus the X index, which was set to 8. So 88, so it's 88 and 89, because it's always 80 plus X plus 1 for the high bit. So we're looking at 88 and 89. So it's looking at DU E9. Always the high bit is always second, so DU E9. So let's go to DU E. Sorry, was it DU or DO? Let's go back just to make sure. Okay. DO E9, right. So DO E9. Getting there? There we go. Is F3, and that's what we've got here for the same. So it didn't load the accumulator with the contents of the 0 page 80. It actually loaded the content, the memory location that was specified in 0 page 80 and 0 page 88. So I hope that explains that. Now the next one is comma Y. Now this is different because it doesn't add to the 0 page location, it actually adds to the address that's found at that location. So if we do 80 comma Y, and here 80, y, but in fact we'll do 88 because that had a better number, and we'll load y with 0 and y with 8. So this should look at location 88, which we know as DOE9, and it should come back with the value that we had before. But this one will look at DOE9 and add 8 to it and get back with a value. So we'll run it and then we'll check that it's doing it. So there's the emulator. So it's coming back with F3, which sounds very familiar, and FF. So we'll go into monitor and we'll go into the memory part of the monitor. So we'll look at 88 just to make sure that it's still DOE9, which it is. So we'll go to DOE9. Not going to believe it. Retro Mark is on the phone again. Hang on a sec, I'll be back in a minute. Right, I'm back. So we're looking at DOE9. So there you go, F3, and then we add the second one is where it was 8 places after this, because the Y index was set to 8. So it's DOE9 plus 8. So 1, 2, 3, 4, 5, 6, 7, 8, which happens to be FF, and that's what we've got here. So that is indirect memory addressing indexed using the Y register. So that was all the addressing modes for load accumulator. Now I've just seen the time and we're well into coming up to half an hour, so it looks like I'm going to have to create another video just to explain all the instructions, like for this one, which is add memory to accumulator, and what those instructions do and how they affect the system. So what I will do is I will sign off with this video and just have it as an explanation of the addressing modes, and then the next video we will do a bit of a deep dive into the instruction set itself and see what it does, and hopefully I'll be able to replicate that using the emulator so you can see actually what it is. So until then, I will say ciao for now and see you in the next video. Ta-ra!